AI, artificial intelligence, has the potential to transform various industries, including civil engineering. In the field of civil engineering, AI can be applied to enhance efficiency, accuracy, and decision-making processes. Here are a few areas where AI is making an impact: design and planning. AI can assist civil engineers in designing structures and optimizing layouts. It can analyze vast amounts of data and generate design alternatives, taking into account factors such as materials, structural integrity, and environmental impact. AI algorithms can also simulate and predict the behavior of structures under different conditions. Construction and project management. AI can be used to improve construction processes and project management. It can analyze construction schedules, optimize resource allocation, and identify potential risks or delays. AI-powered systems can monitor construction sites using sensors and cameras, detecting safety hazards and ensuring compliance with regulations. Smart infrastructure. AI enables the development of smart infrastructure systems. For example, AI can be used to analyze data from sensors embedded in bridges, roads, and buildings to monitor their structural health in real time. This allows for early detection of anomalies or deterioration, enabling preventive maintenance and reducing the risk of failures. Traffic management. AI can optimize traffic flow by analyzing data from various sources, such as traffic cameras, GPS devices, and social media. It can predict traffic patterns, optimize signal timings, and suggest alternative routes to reduce congestion and improve transportation efficiency. Risk assessment and disaster management. AI algorithms can analyze historical data to identify patterns and assess the risks associated with natural disasters, such as floods or earthquakes. This information can help engineers design resilient infrastructure and develop strategies for disaster preparedness and response. It's worth noting that while AI has the potential to revolutionize the field of civil engineering, human expertise and judgment remain crucial. Civil engineers play a vital role in interpreting AI-generated insights, making informed decisions, and ensuring the safety and functionality of infrastructure projects. Certainly. Here are a few examples of how AI has been applied in real-world civil engineering projects. Optimized design of structures. AI algorithms have been used to optimize the design of structures such as bridges and buildings. For example, the AI software developed by MX3D and Autodesk was used to design the world's first 3D printed steel bridge in Amsterdam. The AI algorithm analyzed data on material properties and structural requirements to create an optimized and efficient design. Construction and project management. AI is being utilized in construction project management to improve efficiency and reduce costs. An example is the use of AI-powered drones for site monitoring and progress tracking. Drones equipped with cameras and sensors can capture real-time data, generating 3D models and comparing them against the construction plans. This helps identify discrepancies, track progress, and ensure compliance with project timelines. Smart infrastructure maintenance. AI is employed in the maintenance of infrastructure to enhance safety and efficiency. For instance, the Massachusetts Bay Transportation Authority in the United States uses AI algorithms to predict and prevent subway track failures. By analyzing historical maintenance data and real-time sensor data, the system can identify signs of potential failures and prioritize maintenance efforts. Traffic management and optimization. AI is used to improve traffic management and optimize traffic flow in cities. For example, the city of Los Angeles implemented an AI-based traffic management system called ATSAC, Automated Traffic Surveillance and Control. ATSAC analyzes real-time traffic data from sensors, cameras, and GPS devices to dynamically adjust signal timings, optimize traffic flow, and reduce congestion. Risk assessment and resilient infrastructure. AI can assist in risk assessment and designing resilient infrastructure. For instance, the National Institute of Standards and Technology, NIST, in the United States developed an AI-based tool called SimCenter to simulate and assess the performance of buildings during earthquakes. This tool helps engineers evaluate different design options, predict structural behavior, and enhance the resilience of buildings. These are just a few examples of how AI is being applied in civil engineering projects. The potential applications of AI in the field are vast and continue to evolve as technology advances. Certainly. Here are some applications of AI in material civil engineering, material design and development. AI algorithms can assist in the design and development of new materials with desired properties. By analyzing vast material databases and conducting virtual simulations, AI can identify patterns and correlations between material compositions, structures, and performance characteristics. This enables researchers to discover novel materials or optimize existing materials for specific applications, such as high-strength concrete or lightweight alloys. Quality control and defect detection. AI can be utilized for quality control and defect detection in materials used in civil engineering projects. Machine learning algorithms can analyze images, sensor data, or spectroscopic data to identify defects, such as cracks, voids, or inclusions, in materials like concrete, steel, or composites. This helps ensure the integrity and reliability of materials used in construction. Predictive maintenance. AI can be employed to predict the maintenance needs of materials and structures. By analyzing sensor data or historical performance data, AI algorithms can identify patterns and predict the deterioration or failure of materials over time. This enables proactive maintenance and replacement strategies, reducing downtime and maintenance costs. Material recycling and sustainability. AI can contribute to the development of sustainable practices in material civil engineering. AI algorithms can analyze data on material properties, availability, and environmental impact to optimize material selection and recycling processes. This aids in minimizing waste, reducing resource consumption, and promoting the use of eco-friendly materials. Structural health monitoring. AI can be applied to monitor the health of materials and structures in real time. By analyzing sensor data from embedded or external sensors, AI algorithms can detect anomalies, assess structural integrity, and predict potential failures. This enables early intervention, preventive maintenance, and enhanced safety of civil infrastructure. Optimized material usage. AI can optimize the usage of materials in civil engineering projects. By analyzing project specifications, structural requirements, and material availability, AI algorithms can generate optimized material layouts, reducing waste and minimizing costs. This is particularly useful in applications such as optimizing rebar placement in concrete structures or optimizing the cutting patterns for timber construction. These are just a few examples of how AI can be applied in material civil engineering. The integration of AI in material research, production, and quality control processes has the potential to revolutionize the field, leading to more efficient, sustainable, and innovative material solutions. Certainly. Here are more examples of how AI is used in quality control and defect detection in various materials. Concrete quality control. AI algorithms can analyze images or sensor data from concrete production processes to detect defects and ensure quality control. For example, AI can analyze images of freshly poured concrete to identify surface irregularities or air voids that may impact its strength and durability. AI can also analyze sensor data from concrete mixing processes to detect deviations in material composition, ensuring consistent quality. Steel inspection. AI can be applied to inspect steel materials for defects and ensure quality in manufacturing processes. AI algorithms can analyze images or sensor data to identify surface cracks, corrosion, or other imperfections in steel components. This helps in maintaining structural integrity and preventing failures in steel structures such as bridges or high-rise buildings. Composite material defect detection. AI can assist in the detection of defects in composite materials, such as carbon fiber reinforced polymers, CFRP. By analyzing images or sensor data, AI algorithms can identify anomalies, delaminations, or fiber misalignments in composite materials, ensuring their structural integrity and performance. Non-destructive testing. NDT AI can enhance non-destructive testing methods used for quality control in materials. AI algorithms can analyze data from various NDT techniques such as ultrasonic testing, eddy current testing, or thermography. By interpreting the data, AI can detect and classify defects, cracks, or discontinuities in materials without causing damage, enabling efficient and accurate quality control. Automated visual inspection. AI can automate visual inspection processes for materials and components. By analyzing images or video streams, AI algorithms can detect defects, variations, or abnormalities in materials, enabling fast and accurate quality assessment. This is particularly useful in high-volume manufacturing processes where manual inspection may be time-consuming and prone to errors. Automotive parts inspection. AI is used in quality control for automotive parts manufacturing. For example, AI algorithms can analyze images of automotive components, such as engine parts or body panels, to detect surface defects, scratches, or dimensional deviations. This ensures that the parts meet the required quality standards before assembly. These examples illustrate how AI is applied to improve quality control and defect detection in various materials used in civil engineering and manufacturing industries. By leveraging AI technologies, companies can enhance their inspection processes, reduce defects, and ensure the reliability and safety of materials and structures.